So hello, welcome to the Unity multiplayer system presentation. This is what was previously called UNet. It's being rebranded. I'm probably going to keep saying UNet during the presentation because that's what I'm used to saying. I'm Sean Riley. I'm an engineer on the Unity networking team. And let's get started. So this is a new project. The status of this project is it's in development by a dedicated team. It's in the 5.x timeframe right now. There's a private alpha, and there'll be a beta after 5.0 goes out. And this is going to replace the old Unity networking system that's been around for a long time. So there was a blog post introducing this system that's up on the Unity blogs if you want to look at that. I'm not going to go over everything that was in the blog post that have already been said. So we have big plans, and we have a phased development approach. So the first phase is the multiplayer foundation, and that's what I'm going to talk about today. Next phase is more dedicated servers stuff, and then the third phase is MMOs and advanced tech. Something to note is that phase one doesn't assume you have a dedicated server. It works without a dedicated server. And I'm going to talk about what that means more as we go through the presentation. So these are the components of the multiplayer system. At the bottom, there's a transport layer. In the middle, there's new engine components, there's a C# API, and there's new editor components. And on top of everything, gluing it all together is online services. I'm going to talk about each of these in a bit more detail. So the transport layer is a brand new C++ based, UDP based, high performance transport layer. It kind of looks like a socket API. It sends around buffers of bytes. It doesn't understand your data at all. So it's a very low-level API. But it does have channels with quality of service. So you can create reliable channels and state update channels and unreliable channels, things like that. It's focused on flexibility and performance. So you should be able to do everything with this layer that you can do with a regular socket layer. And exposes a C# API. And there has been a blog post about this already with lots of examples, so refer to that if you want more detail. There's a little bit of transport layer sample code in yellow, if you can tell. So it deals with things like connection IDs, buffers of data, and enumeration types. It's sort of a C-like, socket-like API. So the next components are the engine components, and there's 4 new engine components in the multiplayer system. There's a network identity, then there's a network behavior, which is a new type of script derived from mono behavior, which gives you sort of lots of networking functionality. There's a network transform for doing movement synchronization, and this automatically works with the built-in physics systems, both 2D and 3D. And then at the highest level is a network manager that does high-level network stuff like configuration management and things like that. And we're going to look at all these as we do our demo later. And of course, each of the new components has a new custom inspector in the editor. And we figure because debugging and running networked games is really challenging, we want to expose as much data and detail as possible in these inspectors. So this is not what they're finally going to look like, but the goal is to have as much internal state of the networking system available to you in the inspectors as possible. Okay. Next piece is the high-level API. So this is a new C# API. It's implemented in an extension DLL, just like the GUI system. And it's in a new namespace, Unity Engine.networking. And there's a lot of stuff in this API, lots of services for building multiplayer games. I'm not going to go through them all right now. But this is an API really for game programmers. It's not an API for low-level network programmers. So instead of giving you all the flexibility to do everything a network system can do, this is for making it easy to make multiplayer games and lets you iterate really quickly. And this is a little code sample here. So this is shooting a bullet. So you create a bullet, and then if you're on the server, you say server.spawn my bullet, and then so it kind of looks like game code rather than network code. I'm going really fast, sorry. I have a lot of stuff. The next piece is online services. And this is the stuff to help you deploy and run your game. So these will be things hosted by Unity in the cloud. One of them is a relay server that lets you connect to other players, even if you don't have a public IP, if you're behind a NAT or a firewall or something, so it'll route traffic between players. And we have some matchmaking services, and then there'll be some reporting systems like concurrent user tracking and things like that. And you talk to the online services through either a web service interface or through a C# client wrapper around those web service interfaces that's integrated into the high-level API. And that's what it looks like. You have a matchmaker object, you say create a new match, and you pass it a delegate function that gets called back with information about the match which you can use to create a game. Okay, so some concepts for the high-level API. This is going to help us as we do our demo. So network games have clients and servers, and I'm going to use the word host in a specific way here to mean the client that is also the server. In the little diagram there, you can see one of the boxes has both a client and a server in it, and the other ones are just clients. So the one that is running the server we call the host, and it has what we call a local client, and the ones that are not running servers, we call those remote clients. And it's significant to note that when you're developing your code for the network system, the local client and the remote client can have almost exactly the same code. So your game can run in sort of single-player local server mode and remote mode with the same code. Okay. And this is another piece of vocabulary that we had a little bit of trouble with. Most of the network team comes from companies that have been making online games for a long time, and we were used to the word spawn to mean spawn an object across the network on the client. And inside of Unity, people use the word spawn to just mean create an object. So I'm going to be specific here and say instantiate creates a Unity object, and spawn activates it on the network and spawns it out to the clients. And in the high-level API, once an object is spawned, then it gets managed by the spawn system. So if it gets deleted on the server, it'll get deleted on the clients. If there's state updates, they get automatically propagated. And if new users log in, they get sent the spawned objects with the current state, stuff like that. Okay. This is a quote from a long time ago. Adding multiplayer to a game at the end of development really means adding it in the middle of development. So we don't want that to be the case anymore. Okay. Let's check my time. Wow, that was fast. So what we're going to do for the rest of this presentation is take a single-player game and make it into a multiplayer game. So this is my single-player game. It's got 2D sprites, 2D physics, and it doesn't have any art at all. So we'll do a quick tour of this game in single-player mode. So here, can you see that in the editor? Yeah. Okay. So there's some sprites, there's some prefabs, a bullet, an explosion, a spaceship, and a slime alien. There's some scripts. Here's our scene. You can see there's a big plane with a star background. There's some obstacles. And in the scene, we have a ship, we have a camera and lights, and we have a spawner object for spawning the aliens. So if I say play now, we should see. There we go. We spawn aliens. We can fly our little ship around. We have health bars, and I can shoot the aliens, and they should explode. Oh, yep. There we go. So a simple single-player game. It's a good candidate for making multiplayer. Okay. From current slide. Okay. So what does it take to make a game multiplayer? These are the steps we're going to go through. First, we're going to do our hookup in the beginning, and we have to fix our player movement. We have to fix the way bullets work. Then we have to set up health and damage. Then our aliens and spawners. Then we need to fix our player spawn positions so they don't all land on top of each other when they enter the game. And then we're going to set up a menu, and we'll see if we get that far. Okay. So the first step, we're going to set up some network identities and a network manager. So let me switch back to the editor here. So the prefabs, let's open up our prefab. So the ship prefab has a sprite renderer, it has a rigid body 2D, it has a circle collider. We'll just close those. You can see it has a control script and a combat script. Now, if we go to add component, there's a new section here, network, and we're going to add a network identity. And it has some parameters on it. The only one we really care about right now is the update, the send rate, which is sort of the rate that this object will send updates over the network. And we'll set that to, like, I don't know, 13, nice round number. Okay. And the slime aliens, you can see they have the same combat script. And they also have a slime alien script. So we're going to also add a network identity to our slime aliens, and we'll make it a little bit less frequent, like 3 times. And a bullet will also have to add a network identity. Bullets have a particle system in the bullet script. So, network identity on the bullet. Now, bullets are fire and forget, so we don't have to have an update rate on the bullets at all. Okay, so we have network identities. Now I'm going to create a new empty game object and rename him to be the net manager. And we'll go to the network components again, and we're going to add a network manager. Now this is what lets us manage our network games. It's got a bunch of configuration on it here. This is some advanced stuff we don't care about right now. Then we have 2 scene slots. So let's go to here. So if we look in my build settings, I have 1 scene, the space scene, which is the one we're in. And I'm going to, so what these scene slots mean is that the network manager will do scene transitions when the network state changes. So if you connect to a game, the server will tell you what scene it is, and you can automatically transition to that scene. And if you get disconnected from a game, it might automatically transition you to the offline scene. So what I'm going to do for now is just drag the same scene into both of these slots. Now we have a spawning fold out here, and this lets us control some spawning stuff. So we have a player prefab slot, and I'm going to drag our ship into that slot. Now that means that when a player connects to the game, it's going to spawn that prefab for the player and associate it with that network connection. And then we have a couple of, okay, so my UI, inspector UI is not final yet, so I have to do some stuff manually. So we have also a set of registered spawnable objects, and I'm going to drag our slime alien and our bullet into that. So although the network manager is a new component, it's implemented entirely using the C# API. So if you don't want to use the network manager, you can still use all the underlying stuff in the C# API. And also the C# high-level API is implemented entirely using the low-level API. So you can choose at which level you want to interact with the system. And the components are actually pretty configurable as well, which we'll see later on. Okay, so let's save that. And because we're going to spawn a ship now, I'm going to delete the ship from the scene, and let's run it. So building a standalone player, and here we go. And it looks like there's nothing going on. So that is because the network isn't active. So if this was a real game, you'd have a title screen where you'd say start game or join game or something like that. So for our purposes, though, we're going to use the network manager HUD. So this is a helper component for the network manager. And one of the things it does is that it provides some buttons to let you control the state of the network game. So I can say start as a host. And remember, host means a server and a client in the same process. So when I do that, you notice it switched scenes. It actually reloaded the same scene here. So it spawned a player, and now my player can just drive around, and we're running on the host. So the local client and the host actually share the same scene. They're running in the same scene. So everything just works for the local player. And there's no network traffic at this stage. It's the local client and the server on the host communicate via message queues. They don't talk over the network at all. Okay. So now I can start up my standalone players. So I'm going to do the one on the right is going to be the one on the right is going to be the host. So I start the host, and there he is. It's got a ship. And my client button here is going to default to localhost, so it's going to connect to my local server. So my client logs in, and a ship appeared. Now, stuff doesn't work very well, but we do see there's a connection set up. Ships are flying around, and if I log out my client here by pressing stop, then he disappears, and if I log back in, the ship appears. So it's actually a lot going on under the covers there. So the connections are being established, objects are being spawned, the player is being associated with your connection. So when the connection is destroyed, the player is removed from the game. So there's a lot going on under the covers. All right. So network manager, spawners, and scenes. That's the first phase. So player movement, you might have noticed player movement didn't look very good in that particular demo. So player movement, okay. So to fix player movement, I'm going to go back to our ship prefab. I'm going to add a network transform component. Again, not final inspector UI. So the network transform component automatically understands that we're using 2D physics, so it's set it up as a 2D physics synchronization. I'll configure it a little bit, I'll change that. And there's a checkbox here for local player authority. So that means that for this game, the client is in control of the movement of the player. So the other option would be and it will send transform information to the server, which will then be replicated out to other clients. The other option would be to send inputs from the client to the server and do your movement on the server. But in this case, we're going to do client-based movement. And everything else looks fine there. So I'll save that. And let's see what happens. Okay, so the one on the right is the host, and the one on the left is the client. So I'll start my host, fly around, and the client logs in. Yep, it seems to be synchronized. It's a bit weird, though. The camera's centered on the ship over there in the wrong window. And I don't have the camera centered on me at all. And both ships are firing. But we have movement. Baby steps. Okay. The other thing, my presentation's too long. I was going to synchronize the thrust particles, but I cut that because I didn't have time. Okay, so we have movement. Now we're going to do shooting bullets. And this is going to introduce some new high-level API concepts, commands, and spawning objects. So let's go to the ship again. And the control script, we're going to have to do code for this one. Notice this is the first time I'm hitting code here, and we already have functioning network stuff. So there's a new namespace. I've already imported it. And there's a new network behavior, which is derived from mono behavior. So I'll do a quick tour of the script. So we have a spin variable and a thrusting variable. Some setup stuff here. So in the physics update, if those variables are set, then we apply forces to the ship. In the regular update, we do keyboard handling, and if our keyboard state is different than the old keyboard's input state, then we call our doThrust function, which turns on and off the thrusters and applies that to the variables. And you see here, if the spacebar is pressed, we create a bullet by calling a doFire function, and we center the camera on the ship. So this works great for a single player, but it doesn't work great in multiplayer because both of the ships, or all of the ships, are going to try to grab the camera every frame, and all the input handling is going to happen for all of the ships in the local client. So it's a very common problem, so we have easy ways to fix it. So the network behavior has some flags we can use. So if I look at my base class, isLocalPlayer is a Boolean that's available on the network behavior, and that will be true if this is your local player object, so the one associated with your connection. So in this case, I want to say, if this is not my player, then just return. So no keyboard handling then will happen for other players' ships, and no firing will happen, and the camera won't move. So let's also, I'll put that in our physics update as well. So we want movement to be controlled by the local client, not every player. Okay, so now, let's run it again. Got our host on the right, our client on the left. Start the host, and our keyboards and bullets still work there. And if I log in over here, now we have a ship, and we can see we have movement synchronization, and the camera seems to be working a bit better. Let's see. Yeah. If I shoot bullets now, looks like they're only appearing on the window that has focus. Our health bars are all messed up, but baby steps. Okay. Okay, so we have, I skipped ahead. So now we have our local player check. Let's look at the do fire command function here. So do fire just creates a bullet and gives it a velocity based on your velocity and destroys it 2 seconds later. So that's what we were seeing. The bullet was being created on the client and fired off, so the other client or the server didn't know anything about the bullet, so nothing was in sync. So what we really want is the bullet to be created on the server and then propagated out to the clients. So the way to do that with the high-level API is a thing called a command. So I'm going to make this into a command. And a command you invoke on the client, and then it's automatically called on the server instead of on the client. And the way to do this is you add a custom attribute to your function. And I'm going to rename it command. And now, let's compile that. So now that will just be called on the server instead of on the client. And all of the parameters for that function get automatically serialized and invoked on the server with the same values. And this is not quite everything we need, because now the bullet is only on the server. It was only on the client, now it's only on the server. So this code is running on the server, so we can say network server.spawn bullet. And because we registered our bullet with the network manager as a spawnable object, it understands the prefab, the way the prefabs work. It will just spawn a bullet on the clients now, and it's going to do automatic serialization of state for that bullet. So even if you enter a game and a bullet is in the air, you'll be sent that bullet with the right state on it. It's not. So, and this is a little significant as well. So the destroy is going to still happen on the server, but because it's a spawned object, now it's being tracked by the network system, and as soon as it's destroyed on the server, it'll get destroyed on the clients. Okay. So let's try it out. So there's our host. It's our client. Log in, shoot a bullet, and well, there seems to be bullets appearing, but they're not going anywhere on the other guy. That is because our bullet doesn't have a network transform. So let's go here and add a network transform to a bullet. Now, bullets, we don't want local authority, and they're just circles, so we don't want to sync any rotation. So that's all we need for a bullet. So let's, one more time. So there's our host, and here's our client, and now if I shoot a bullet, yeah, we can see bullets are appearing, spawning and disappearing. Thank you. Okay, you'll notice our health bars aren't synchronized. I think that's the next step, yeah. Okay, so that was spawning and commands. So the next step, we're going to fix up the combat. Health, in this game we want health to be controlled on the server and then sent out to all the clients. Damage needs to work on the server, and death and respawning as well. So let's go back to our ship. We have a combat script on the ship. We'll open that up. So this is a combat script, and this is on both the ship and the aliens. So we can see there's a health variable on the combat script. This is also a network behavior, just to save typing. I already set that up. So we have a health variable. We have a function to take damage, and that just reduces your health by that amount. And then if you run out of health, you either respawn if you're a ship, or you get destroyed if you're an alien. And there's a function to make an explosion. There's a function to respawn you back at the center position, and then there's just some old GUI code to draw your health bars. Okay, so what we want is health to be a server-side variable, and the way we do that is we add a custom attribute, call it the sync var. And now health will be synchronized out to the clients anytime it changes automatically. And because so local clients and remote clients both work the same way here. Let's see. So our take damage function, we only want to work on the server. So we're going to use one of our built-in flags again. I can say if is server. So if this is not the server, then we don't want damage to be applied. So I'm just going to early out of this function. So now, just look at the bullet script. So if you're a bullet and you collide with another object, if it has a combat script on it, call take damage and destroy yourself. So that's fine. That can run anywhere. We don't care. That can run on the client. That can run on the server. Bullets destroying themselves on the client is fine. So, and then the take damage function will work on the server and do nothing on the client. Okay, so since this function is now only on the server, we want to remove our effects code from here. It's not very good effects code, but it's effects code. So explosions, no explosions on the server. And let's see. So let's see. Let's go to my ship prefab here, and if I look at the, where are we? Combat script. Did I not save that? Let's see. Ship combat script. Okay. Now we can see that you might not be able to read this, but there's a annotation here to say this is a sync variable. So this is a server-side variable. So actually, I'm just going to turn off our alien spawner for now so we can look at our health bars without being bombarded by aliens. Oops, it was already running. Okay. Okay, host on the right, client on the left. So, client logs in, shoot the host, you see his health goes down. There's no explosions anymore because we took that code out. If I log out of the client and log back in, we should see the health bar on the server pilot is the correct value. And there we go. So that's what sync vars do. Okay, but we don't have any explosions. Where's my PowerPoint? There we go. We have damage, but we don't have explosions. So we need to fix the explosions. And there's a few ways we could do that, but the way we're going to do it here is we're going to add a hook function to our sync var. So I'm going to say on damage. And then I need to implement a function of the same name. And that's going to be passed new health, because this is a hook function on the health sync var. Now, I would actually get a compiler error if I didn't spell that the same as the name of the function. It is type safe. Okay, and now this function will be called on the client anytime your health changes. And because local clients and remote clients are the same, it will happen on the server as well as on the client. So I'm going to set the health to the new health. And if new health is less than 100, which I know is your starting health, I'm going to say make explosion 0.3 seconds. So now we should see that anytime you take damage, there should be an explosion. And that will work on the aliens as well as on the ship, because the aliens have the combat script on them as well. So there's my host. Fly a little bit. There's my client. When I log in, I shoot, and we see an explosion. And it's happening on both the client and the server, because it's a local client and a remote client. Shoot him, and we should see a little explosion. If I shoot him more, yeah, he's dying, but he's not respawning. I think that's the next step. Right. Okay, so let's look at our combat script again and the respawn function. So this is only happening on the server, so that's good. And what does the respawn function do? It says your health, and it moves your position. So that's not going to work anymore, because in this particular game, the client is in control of the position. We do need the health to be set up, so let's break it apart a little bit. So the server is going to reset your health to 100. And then the respawn function, we want this to be called on the clients. So there's a way to do that with the high-level API. We make this into an RPC call. So I add an attribute here, client RPC. Come on. Client RPC. So commands are called on the client and invoked on the server. Client RPCs are called on the server and invoked on the client. And they're invoked on all of the clients, not just one client. Oops. So now when on the server you respawn, it's going to tell the client to change the position of the ship. Now we only want to do that on the local player, so I'll add a local player check here. So if this is the local player, respawn the ship. We don't want the other players to be respawning a ship when he dies. And let's try that. Let me check my time. Plenty of time. Okay. Oh. RPC respawn, thank you. Okay. So now when a player dies, we should see them respawn with the correct amount of health on both the client and the server. So here's our ship. Fly a little bit. Here's our client. I'll fly down here and shoot him. And it looks like it worked. He's got all his health and he's back at the center. But he didn't explode. That was no good. We need explosions. Okay. So the client respawn function, we're going to add an explosion. There we go. A big explosion, 2-second explosion. Okay, so now, when the ship respawns, we'll see an explosion. And because, once again, the local client and the remote client will both create explosions, it should work on the client and the server automatically. It's my host. There's my client. So shoot him, and boom, air exploded. And the explosion appeared on both the client and the server in the right place. Let's do that again. Boom. Okay. So, death and respawning, taking damage, seems to be working. Okay, back to the aliens. So, the aliens, we need to fix our spawner. Spawning should only happen on the server. We need to fix our alien movement, and we need to fix the way aliens die. Okay, so let's go back to our alien prefab. See, we have an alien script, and the spawner, we have a spawner script. So let's turn the spawner back on, and let's look at the spawner script. Oh, I'm going to have to make this a network behavior. So this is a pretty simple script. Just when it starts up, it creates some aliens. But that's not entirely what we want. We only want this to happen on the server. So I'm going to override. So the network behavior has lots of functions that you can use to override. So I'm going to override onStartServer. So now this will only be called on the server. It won't be called. So the regular start is called everywhere, but this is only going to be called on the server. So now, when the server starts up, the spawner will be created, and this function will be called. It's not quite enough because the aliens need to be spawned. Remember, instantiate and spawn are slightly different things. And since this is on server code, I'm going to say network server.spawn, and I have to cast this guy to a game object. Oops. Okay. So now, go back to it. I have to add a network identity to our spawner here since he's now using a network script. There is a dependency between those two, but because of the weird ordering I did this in, I just have to add that separately. And you notice there's a checkbox here, server only. I can check that for the spawner, so that object won't even exist on non-server clients. Okay. Just make sure I saved my code. Yep. Okay, so now the aliens should be spawned on the host. There they are. And then I'm going to log in with the editor here. When I log in, I can see the aliens, and they should have been. So they started in the same positions, but they're not going to move in concert yet. There's a couple of problems with the aliens. So one problem is they don't have a network transform. So if they were moving on the server, that data wasn't being replicated out to clients. So let's add a network transform to the aliens. And the server authoritative objects, so I don't think there's anything we need to change there. And then let's take a look at the alien script. Where are we? Aliens, slime alien. Okay. Okay, so a quick tour of this script. As an update, okay, aliens have a player target, and in their physics update, they'll move towards the player target if they have one. And in the regular update, they apply some random jitter so they don't move in straight lines. And then they check if there's a player in range and they set their target. And if you collide with a player, you do damage to the player and destroy yourself. Actually, is it true? If you collide with the player, you do damage to yourself enough to kill yourself. Okay. So, this is a network behavior. And we only want this code, this is enemy AI code. So we want this to run only on the server. So I'm going to say if not server, if not server, return there. No, that's backwards. If not server, return. That's right. Okay. And I'll put that in the physics update as well. Okay. I think everything else should just work. I mean, the damage function already only does things on the server. So let's see what happens. This is a pre-alpha build, so if there's red showing up in some console windows, just ignore it. Okay, so there's my ship on the host, and my client logs in, and we should see the aliens are all in the same positions. Oops, wrong one. It's a bit hard to see, but yeah. And if I shoot them, then they take damage and they explode because they've got the combat script on them. And so that seems good. Let me do that again. So, okay. Notice I stopped the server, the client got automatically kicked back there. So let's start that again. Oops. Oh. And when I shoot aliens, there's no explosions. We need explosions. Yeah, they just disappear right now. They take damage because we have a hook function on the sync var, but there's no big explosion. Okay. So, alien spawner, alien movement, death, right. Okay. So to do the explosion, I'm going to go back to the combat script, and we're going to override another one of the virtual functions on our network behavior. So public override void on, devoid, override void on network destroy. So this function will be called on a client when it is despawned in a network game. And because our local client and our remote client are the same, it will get called on a host as well as on a remote client. And in this function, I'm just going to say make explosion 1.6 seconds. So a slightly smaller explosion. Okay, so he's already still running. So now we should see our aliens explode when we shoot them on both the client and the server. So there's our host. Windows fighting me. And when client comes in, yeah, you can already see, shoot the alien and boom. Yep. I'm just going to play the game for the rest of the talk. No, not really. Okay, so aliens, spawning, death. Yeah, I was going to do scoring, but my demo's too long, so. Next thing is player spawn positions. We don't want players all spawning at 0, 0 all the time. We want to be able to customize that. And there's two easy ways to do that. One of them is on the network manager here. We see there's a slot in the spawning section that says player spawn location, and you can put a transform object in here. So you can put any game object transform in there and control it with script if you want, move it around, and then when the player enters the game, they'll spawn at that location. Another way to do this is to override the functionality of the network manager. And we're going to do it that way. So I'm going to actually remove these components and add a new script. I'm going to call this the space manager. Space manager. Oh, what happened there? Okay, so the network manager has a new script, and it's going to open that up. And I'm going to cheat. I have some code to paste in there. So the space manager, this is going to be derived from the network manager class. The network manager is a mono behavior. And there are lots of virtual functions on the network manager that you can override to control its behavior. So if I say on, you can see there's things like when a client connects to the server, when a server gets a connection from a client, all of these things you can control. In this case, we're going to override the functionality of when a player is added to the game on the server. Now the default functionality here is to instantiate the player prefab at the position of the spawn object, or at 0, 0 if there was no spawn object. And call, this is an API function, you have to call network server.addPlayer on your player object to associate it with the connection. So we're going to do almost exactly the same thing, but we're just going to move our spawn object a little bit so it's not directly on top of the original spawn object. Okay, I'm going to have to reset up my network manager here. Okay, let me just wait for this to recompile. Okay, so our space manager script is derived from the network manager, so we still get the custom inspector for the network manager. So all the configuration stuff is still there. but I'll have to reset it up because I removed that component before. So I'll just drag these in and drag my player ship back in here, and manual UI. Add my, yeah, spawning, and my alien. Okay. Let's just make sure stuff still works in the editor. Oh, we don't have any controls. I had to remove the HUD component, so I'll re-add that as well. So now we have our HUD back. I can start the host, and stuff still works. What does my time look like? Okay. So take a minute here and take a quick look at the HUD manager. I don't know how well you can see this on that screen, but I can open up this guy and see a bunch of information about what's going on here. So I can look at the number of connections there are on the server. There's only one right now, and it's a local connection. I can look at the objects that are registered with the spawning system. And if I want to, let me create some bullets, and you'll see they should appear over here and then disappear when they despawn. And you can see what game object is associated with which connection. So this lets you sort of drill down into what's going on inside the network, and really helps when you're debugging network applications. There's also some control stuff. Let's see. This button in the inspector does the same thing as the stop button over in the runtime. So if I stop that, stop, and these buttons do essentially the same thing. So if you're not using the default HUD, which there is a flag for that, you can still control your network from inside the editor without any UI. Okay. Where was I? Spawn position. Okay. So let's just check that our spawning code worked. So I'm going to create a host, and then when my client logs in, he's in, and because it was connection ID multiplied by your starting vector was where your position was. So if aliens are messing up my codes. If I created another client and logged him in, we'd see he also spawns. Let's do another one. All right, let's do lots of them. Which one's the server? It does say up here, yeah, this one's the server. So they all got kicked out. Now I'm going to restart the server, and before all the aliens come along, client, client, client. See, they're spawning in a line because it's connection ID multiplied by your forward vector is the spawn position. And you wouldn't do that in a real game, but you can see you can control the behavior of the network manager by overriding those functions. Okay, let's see. I might make it. Right, so we don't want to use our ugly old UI, so we're going to make a new UI using the new UI system to control our game. So I'll save this scene. I'm going to make a new scene. And I'm going to save this scene as our menu scene. Okay. A little bit of setup to do now. So the network manager is in the space scene right now, so I want to move it to the other scene. So I'm just going to copy and paste that guy. Save that, go back to our space scene, and delete it from here. Okay, back to the menu scene. Yes, save that. Now I need to open our build settings and add our menu scene to the build settings, and I'm going to drag it so that it's the first one. So we start up on our menu scene. Okay. Now the network manager needs to be told that the menu scene is the offline scene and the space scene is the online scene. Okay. And everything else should still be there, because it's serialized it all. So our spawning ship is still there. Yeah, our spawners are all set up. Okay. And now we have to add some UI. So I'm going to create a button. All right, new UI. And the button I'm going to change to be Start Game button. And I'm going to add a handler for this button. And I'm going to point it at the Network Manager object. And I'm going to call the Start Game function. Okay. So let's just run that in the editor and see what happens. I don't need that anymore. So let's turn off the ugly runtime GUI. And now we just have a title screen with no title and a Start Game button. So when I hit the Start Game button, it automatically switched to the online scene and started the host up. And I can still control it from our Network Manager HUD over here. I can say Stop Game, and it automatically switches back to the offline scene. Okay, so to do this on a real network, we need another button. So I'm going to add one more button. Button. It's in the wrong place. Button. Label, I'm going to call this Join Game. And at our handler, again, we're going to hit the network object, Network Manager object, and I have a function on here in our Space Manager script for joining a game. Now, this will only work on localhost because you'd have to add some more UI to let you like enter an IP address or interact with the matchmaking system to find a real game. But for the purposes of our demo, that should be fine. Okay. So I'm going to start a game here, fly around a little bit, then join a game here, and where we go? We join the game. Okay. I'm going to do this in the editor now. So if I start a game here, I'm going to run a couple of clients, join game, everyone's happy. If I go to the editor now, let's go to my Network Manager. We don't have a UI to do this in the real game, but I still have my UI here in the editor, so I can say, let me just, okay, make sure we can see these guys. So if I say, where is it? Network Manager Stop Game, those guys got disconnected from the network, so they automatically switched back to the title screen. So the Network Manager is doing scene transition management. Thank you. All right. That's all the demo I have. So this, go back to my slides. So future stuff, this is stuff that we plan to do in the sort of the phase 1 time frame, but it's not quite there yet. Host migration. So when there's no dedicated server, if the client that is the host gets disconnected, we need to be able to recover that game and transition the host to another client. Some games that's possible, some games it's not. So where it is possible, we want to support that. Visibility rules for area of interest. So these are difficult network problems, stealth, fog of war, visibility range. So we're going to have support for those. We're going to have more low-level tools, simulating network conditions like lag and jitter and latency, packet logging, replays, stuff to help you debug your online systems. And more online services are going to be coming too. And I think that's it. Those are the links to the blogs. It's my email and the email address of Eric Jewell, who is the lead on the networking project. I have 5 minutes, so a question.
So thank you.
Can you talk into the microphone, please?
Sure.
Yeah.
So it's future work for like stealthing and things like that. Is there a way in the API that will exist on first release to determine which objects get serialized to which clients, or is that not possible with the phase 1 UI or phase 1 API?
Yeah, that is the plan, to be in phase one, to have, it'll be, we call it a area of interest system, and it'll have ways of implementing those common cases and also sort of completely custom cases that you come up with. That's the plan, yes.
Okay.
Yeah, next question?
Is the networking system implemented in such a way that you could replace the transport layer underneath the high-level API?
Not right now. It has come up, but that's something that is still, there are technical issues with that. There are also business issues with that, and I can't really talk to the business side of it. So, yes, it's a complicated issue, but we have talked about it internally. I'm sorry, I don't have a great answer there.
Hi.
How do you deal with client and server authority? So how do you force game state and resolve any kind of conflicts?
How do we resolve conflicts with client and server?
Yeah, so you can check if it's going to be client or server authority, and you said like ball is going to be server side and client, like player is a client side. So how do you, like, if
So-
there's a conflict, how do you solve it?
So okay, there is game state data and there's movement. And in the high-level API is server authoritative about everything except movement. So all of the game state, like the sync vars, the server is the absolute authority on those. They get replicated out to clients. And clients never change the values of those values. So there's no conflicts on game state data. But
the movement itself, so you can render like a client on the server side in one position, but on local game you can render in another position. So when you try to hit something, and for example you need to lead your target, how you handle that? Like, do you roll back maybe and then recalculate state? How do you do that?
Okay, yeah, so movement is a separate, we're treating movement as a very separate problem from game state data. And the network transform component is a fairly generalized movement control system. I know that there are more sophisticated sort of FPS style systems which have client prediction and hitbox tracking and all that. The initial release won't have all that sort of FPS style stuff in it, but it's certainly on our radar, yeah.
Okay, do you use any data compression, like you using remote procedure call and you just serialize stuff, so it can make a package huge, which not gonna good over internet place. So do you compress in any way, maybe delta compression?
Yeah, all of the synchronization for state variables is delta compressed, and we also do variable size compression on integers. So smaller integer values get compressed into smaller space than large integer values.
Okay, and is it possible to use reliable and not reliable packages? For example, like if you pick up an item, you should know about it, but if you do something minor, like can you like mark something as reliable or not reliable?
Yes, the transport layer supports different channels with different quality of service levels, like reliable, unreliable, and such. And there are, so the custom attributes that we put onto things to tag them as networkable, some of those are parameterizable by telling it which channel their traffic should go over. So you can say that this sync var should go over an unreliable channel. So.
Okay, thank you.
Okay, thanks.
You mentioned earlier on a slide that Unity is providing a relay server service for connectivity issues, and it's the biggest problem in mobile gaming. Is that going to be a paid subscription service, or is that going to be something included?
I cannot answer that question, I'm sorry.
All right, thank you.
Hi, I was wondering about the SyncFar stuff and the RPC stuff, and was wondering if it had the same restrictions as the previous RPC calls and such things like that, as far as what variable types you can sync and send across when making those calls.
Yeah. Well, you can send basic data types, you can send structs, you can send arrays, you can send arrays of structs, you can send references to net spawned game objects, and that's where it ends at the moment.
Okay.
So you can't send arbitrary classes, yeah.
I was curious if you would publish your protocol so we could use your editor and scripting goodies with our own servers.
The plan is, yes, to publish the low-level API protocol, but don't quote me on that.
Hi, can you tell more about the rigid body?
Just one quick follow-up.
Yeah.
We're hoping to have a Wireshark plugin for our protocol as well. Yeah. I'm sorry.
Sorry, it's okay. I've seen that you're synchronizing physics as well. Can you talk a bit more about that?
Yeah, the network transform component works with physics, yes.
Does that mean that on the client it's a real physics as well?
Real physics?
Well,
yes.
the rigid body is also on the client?
Yes.
So it can interact and collide with local physics that are not
Yes.
meant to be networked?
Yes, it can. Okay.
It seems like there's a lot of commingling between client and server logic in the scripts. Is that something you guys are going to sort of enforce as far as separating them and going forward?
That's a good question. So phase one is really targeted at not dedicated servers. It's environments where one of the client is the server. So it's different than in a dedicated server environment where you have like different build targets for your server and different different code that's running there and is running on the client. In this phase, the server code is running on the client as well. So you can't. I guess you could completely disentangle them, but.
So right now it's on the programmer's sort of task to do that on its own. But I was wondering if you guys are going to do that sort of for us in the future.
Yeah, and there's sort of a philosophical question there is. We want to enable sort of end-to-end feature development, networked feature development. So if you're writing sort of a component to do something in a networked game, we want one person to be able to do it completely on the client and the server and the effects and the UI and everything and have that be sort of a one piece, not be one guy has to write the client bit and one guy has to write the server bit and they don't talk to each other. So in that scenario, sort of the code is intertwined.
And obviously it's just a security issue going forward. People are going to be cheating if they can, right? So.
Yes.
Will the previous like 4.0s or 4x's networking be still supported in 5, or is that going to be completely gone? And how hard would it be to move some code from that old way of networking to this newer, much better way?
So in 5.0, the old networking system will still be there. In the release that contains the new networking system, that will be removed. So yeah, and RackNet will be removed as well. So transitioning, they're very different systems. So transitioning really is going to be up to you. Okay, thank you very much. No more questions, I'm done.